Hi. We're from Group 21, EKC 222, Chemical Engineering Thermodynamics. We're going to share with you the latent heat of pure substances. Let's get started. First of all, what is the latent heat of a pure substance? The latent heat of a pure substance is defined as the heat or energy that is absorbed or released when a substance undergoes a phase change. At constant pressure with no change in temperature, a pure substance either liquefies from the solid state or vaporizes from the liquid state. The latent heat of vaporization is defined as the amount of heat needed to convert 1 mole of liquid into a different state at its boiling point under normal atmospheric pressure. When a liquid substance absorbs energy, it transforms into vapor. The latent heat of fusion is defined as the amount of energy required to cause a change in a solid's physical state and turn it into a liquid when the environment pressure is maintained at a constant level. Here is the historical development. The term latent heat was introduced by Joseph Black. The latent heat term is derived from the Latin word latens, which means lying hidden. In 1750, Joseph Black introduced the concept of latent heat into the field of calorimetry. In 1761, Joseph Black discovered that applying heat to ice at its melting point causes an increase in the amount of water mixture rather than an increase in the temperature. Joseph Black discovered that applying heat to boiling water causes an increase in the amount of steam rather than a rise in the temperature of the steam mixture. Joseph Black concluded that the heat must have become latent as a result of combining the ice crystals and boiling water. The theory of latent heat is the conception of Thermodynamics.at. Next, we move to theories. When the ice melts, the phase transforms from solid at its melting point to a liquid with a constant temperature at 0 degrees Celsius. Then, when water boils, the phase transforms from water at its boiling point to a vapor with a constant temperature of 100 degrees Celsius. The heat of fusion for water at 0 degrees Celsius is approximately 334 joules per gram, and the heat of vaporization at 100 degrees Celsius is about 2230 joules per gram. As the heat of vaporization is so high, steam carries a great deal of thermal energy that is released when it condenses. Here is the graph of the phase change. In this graph, some degree of energy is added to ice. The temperature of the ice rises until it hits 32 F, at which point the substance doesn't change temperature and it is now in the latent range. Once all of the ice has melted and the substance becomes fully water, the temperature begins to rise again and we are again in the sensible range. Once the water begins to vaporize, the temperature stops rising and we are again in the latent range. The temperature does not rise until all of the water has vaporized, at which point the steam continues to get hotter as more energy is added. Equation of latent heat is delta H equal to T multiply delta V multiply dP saturation over dt. The derivation of this equation, known as the Clapeyron equation, but, if the data required in the equation are not available, for latent heat of vaporization, there are other ways to calculate it. There are two ways to predict the latent heat of vaporization. First, the estimation of the normal boiling point by Trouton's rule. The second way is the estimation of the heat of vaporization at any temperature from the known value at a single temperature. To understand more about this method, let's look at the example. This solution was done using MATLAB software, so we can see that the value of the latent heat of vaporization of water that we got from this method is not far from the value from the steam table, thus, this method is acceptable. Here are all the references for our topic, latent heat of pure substances. That's all from us. Thank you for watching.